Have you ever thought about how a ship floats while a piece of iron sinks? Do you have any idea about the science behind the hot air balloon? Well, the answer is very simple. The mystery behind both of these things is Archimedes' principle. Assalamualaikum and hi everyone. So I'm NADEIANA BINTI HASRIM from SMK Abdurrahman Talib, Kuantan. Will share my knowledge with you on how can ship floats and what is Archimedes' principle. Archimedes introduced the principle of buoyancy to the modern world. Ships, swimmers, hot air balloon and submarines all function on the same principle, and I will explain how it all works. Archimedes stated that an object immersed in a fluid will experience an upward force from the fluid. The upward force is equal to the weight of the fluid displaced by the object. Figure shows the forces acting on a ship floating on the surface of the sea. The forces acting on the ship are in equilibrium. The resultant force on the ship is zero, hence weight of the ship is equal to buoyant force. Based on Archimedes' principle, buoyant force is equal to the weight of water displaced. Then, weight of the ship is equal to the weight of water displaced as well. Moreover, volume of seawater displaced is equal to the volume of the section of the ship immersed in seawater. This shows that an object floating on the surface of water needs to displace a volume of water which has the same weight as the weight of the object. So guys, is there any difference between ship floating at the sea and a canal? The surrounding does not affect the floating of the ship. Therefore, ship able to float at the sea and a canal as long as the volume of water displaced is equal to the volume of the section of the ship immersed in the seawater. On the other hand, according to Archimedes' principle, the design of a ship must ensure that it can displace water equal to the ship's own weight. The structure of the ship is very important when it comes to floating. The design of the ship must ensure that it can displace water equal to the ship's own weight, as stated by Archimedes' principle. The most important part of the design is the hull. The hull of a ship consists of hollowed-out shells of steel that contains an adequate quantity of air. It makes the ship less dense than water. Besides, the volume of air in the hull determines the floating and the load-carrying capacity of a ship. In addition, the density of the ship, including the cargo, crew, and components, must be less than the density of water in order for the ship to float on top of the water. Next, a particular important feature in the hull is its marking, referred to as the plimsoll line or water line. Invented by English politician Samuel Plimsoll, these markings determine the load-carrying capacity and the space available for new cargo. They indicate the greatest depth a ship can immerse itself within. Plimsoll line indicates the safe level of immersion. When the ship is immersed beyond the plimsoll line, it will sink instead of reaching the destined port. If you see a ship launching video, then you might have noticed water rushing to the shore when the ship enters the water. This is because the ship displaces water equal to its weight and will immerse at a particular level in the water. The air in the hull makes the density of the ship lower than the density of water, so the buoyant force exerted on the ship by the water is higher than the downward force, thus allowing the ship to float in this condition. Thank you for watching. I hope all of you gained a lot.